Violet here. I want everyone to think of your favorite planet. Okay, give me your favorite planet.
Saturn.
Saturn, right. That is a planet inside our solar system. That is not an exoplanet.
Huh.
What are exoplanets? Exoplanets are all the planets not in our solar system. So the ones in our planets are not exoplanets. But, well, the planets not in our solar system that orbit other stars. That's the most important part, is that they orbit other stars that are completely out of our solar system. The exoplanets we are mainly concerned about are the ones that can harbor life forms. How many exoplanets are there? Well, the first confirmed detection of an exoplanet occurred in 1992. As of the 1st of January 2019, there are 3,946 confirmed planets in 2,945 systems, with 650 systems having more than one planet. Astoundingly, there are estimated to be over 40 billion Earth-sized potential exoplanets in the Milky Way galaxy. Now, finding exoplanets is a piece of cake, a piece of difficult cake. There are technically six ways to find exoplanets, but there are four main ones, which are transit, radial velocity, direct imaging, and gravitational microlensing, but I'm only going to be talking about the transit and radial velocity. The transit method measures the dimming of a star as the exoplanet passes in front of its light emission, which I have a video of right here. So essentially what's going on here is as the planet passes over the sun, the dimming of the sun allows us to, well, we detect the dimming of the sun and we are able to detect that there is a planet going in front of the star. Essentially, that's how we found, that's the transit. And then the radial velocity method goes like this. As the gravitational pull of the star and the planet pull on each other, the redshift and blue shift essentially. They I mean, it's pretty simple. We can observe the star being pulled by the gravitational pull of the planet.
Very minutest amount of pull.
Yeah, tiny. Like this is an exaggeration. Like it's very small. It's pretty difficult to find. It's done it again.
Yeah, it does it every day. There are no answers.
Okay, now the Kepler telescope. Launched in 2009, this space telescope is primarily used to find exoplanets and find other things, I think, but mainly exoplanets using the methods previously mentioned. And I just wanted to direct your attention to, well, here's the Kepler, and then this sort of, I don't know, it's sort of a timeline deal. It starts with ground-based observatories, and then the Hubble, which was the first, main telescope, and then we get all the way to here, which is the Kepler telescope. And then here's the James Webb telescope, which if you remember I talked about a few weeks ago. That it hasn't been launched yet, but it will be launched, and they keep pushing that date. Kepler 452b. This is just one exoplanet, one example of an exoplanet that is 1,830 light years away from Earth. It is 5 times as massive as Earth. It has twice Earth's gravity. 50% larger radius compared to Earth, orbits the G-type star Kepler 52, thus the B, in 385 Earth days. So the year is only 20 days longer than a year on Earth. And it lies within the habitable zone, or the Goldilocks zone. The Goldilocks zone is, this shows it pretty perfectly. This is our sun, and then that's the Earth. It sits right in the middle where it's not too hot for life and not too cold for life. So everything is just perfect. Like, the story of Goldilocks. It was just perfect. Now, please consider the following. This is our sun is right here, and then this circle here is roughly all the exoplanets we observed is in this circle. So how is it that just this galaxy, how could there not possibly be life in just this galaxy when we are observing planets that could very well possibly have life in this circle, this tiny area of the Milky Way. That is all. Any questions?
And it takes, with the methods that we use, that star and planet have to be oriented relative to us in order for that to work.
Yeah.
Yep, and so, it's awesome. Absolutely awesome.
All right. Any questions? All right, thank you.
And now we're gonna hear about some exoplanets. Oh, you want me to? You see these names on exoplanets, a lot of times what they do is they'll give you the star name, and that's like the A, and then the B would be the closest planet, and then C would be the next planet, D would be the next planet, and so on. So that's how they do the naming on those things. So when you see that, what was that, 452b?
Yep.
That would be the closest planet that we discovered to Kepler 452. I'm ready.
Okay, so
Am I,
you need to.
yep.
So my name is Kylie. For those, since we've been on a long break, my partner Brenna is not here tonight.
Is your other?
So I will be attempting to present this and hers. So bear with me.
You'll be fine.
Okay, so we have exoplanets, we have part 1, Zach has part 2, he has more. So, this is Gliese, I believe, 581c. Okay. All she has down for notes is that orbits a red dwarf star, so you can see, and this is kind of just an artist's perception, so what they believe it looks like.
So we talked about this being planet C, so that's likely planet B right here, and maybe the moon.
And then, okay, so it is tidally locked. Atmosphere is like Venus, and this planet was discovered in 2002. And then 13 days to orbit its host star, and then it's close to Earth. It's the closest to Earth, and it's 20.3 light years away. But as you can see, it has a very Earth-like surface. So
Could have.
this is again an artist drawing, but you can see that they're expecting it to have water and then some land and a good atmosphere. And then her next one was Gliese 667cc. It is 23.2 light years away, and then it was discovered in April 2012. And then it's the most Earth-like exoplanet that is out there that we have discovered so far. This is again an artist interpretation of what it would be like on the surface.
We're thinking that's probably one of its stars there, but we're not sure if these are 2 other planets here, or, because it's a double star system, right?
Yeah,
So we're not really sure what this.
yeah. And then it is 4.5 times the size of Earth, and it takes 28 days to orbit its host star. And then it's in the habitable zone, not too hot, not too cold. So it's kind of like what Violet said. We are in the perfect area to where if we were a little bit too far away, it would be too cold. And if we were too close, it wouldn't be very good at all. We would burn up. So this place is like in the Goldilocks zone in its area.
Do you know, sorry to interrupt, does that orbit both of those stars or just one of them? How does that work?
I'm not sure.
We think so.
Wow.
Yep, yep.
So it's this huge orbit and the 2
Yep.
stars themselves are.
Yep, and I think,
Each other.
at least from what I've read, a lot of times we see that, but these planets have wicked orbits, where the chance of finding life is, I would say they couldn't. Maybe that's not their #1 target to look for life.
Stephanie and Brianna will talk more about double star systems.
Okay, so I have 55 Cancri E. it's in the orbit of star 55 Cancri A, so it is the fourth star in its system. I'm not sure what the other 4 are, but I just do know that there are 4 other planets in its like planetary system. And then the mass is 8.6 times the size of Earth, and then the diameter is 2 times the size of Earth. So it's a pretty decent size exoplanet. It is the first classified super-Earth discovered around a main sequence star. And then it takes 18 hours to complete an orbit. Innermost known planet in its planetary system. So it's the closest, if I want to say, right? And then this is just a picture of its general direction, and it is in the constellation of Cancer. So you can kind of see it right here by Pollux and all the other cool stars. And then I also had WASP 12b. And so you can see right here, fun fact, you know how most planets you can see how light kind of reflects off? This planet doesn't reflect, it just absorbs the light. So it is known as a pitch black exoplanet, and it's like, just like nothing. So it's an extrasolar planet orbiting the star WASP 12, and it was discovered by the Hubble telescope. Due to an extremely close orbiting star, it has one of the lowest densities of exoplanets. The planet only takes about over a day to orbit its star, and it's about 1/44th distance of like Earth's distance to the sun, and then on this. Okay, yeah. So in 2013, scientists at NASA discovered that there is water in its atmosphere. And okay, so then I had sweeps 11. Yeah. And then this is a size comparison to Jupiter, right? Yep. And so, and it's in the constellation of Sagittarius, and it's approximately 27,000 light years away from the sun. So it's pretty far.
That might be one of the farthest.
It's the farthest known exoplanet in Earth that we know of right now. And it was discovered in 2006, and its orbital period is 101 hours, and the paramagnitude is 18.8, and then it's also 9.7 the radius of Jupiter, and 1.13 times the mass is 9.7 of Jupiter, and then 1.13 times for radius of Jupiter. So it is a huge exoplanet, like huge. Jupiter's not a tiny dude.
No.
So, but yeah, so it takes about 1.8 days or 43 hours to orbit its star. And then that's our works cited. Any questions? I tried my hardest.
I have a question.
You're fine.
The dark planet,
Yes.
why doesn't it reflect light?
Scientists are thinking it's due to the the liquid on it. I'm not quite sure why, but they said it might have something to do with like the atmosphere of it. But again, they're still trying to discover why it is just absorbing light and not reflecting. So, Stephanie.
Okay, how can we find it if it doesn't reflect any light?
We use that, what like Vi talked about, we look at the dips in the sunlight, or the dips in the light from that star.
Okay.
It's kind of like how
Gases
we
in front of it.
how do we know black holes are out there?
Yeah.
So it's
We
kind of
look
like.
for
The
indirect.
light around it.
And then Lucas, you had a.
It was the same one.
Oh, okay.
I had a question.
Yeah.
When a planet like that last one is that close to its star, and it's really massive too, I'm not sure what massiveness would matter, but is that stable? I mean, would a planet stay in that kind of an orbit, or are we seeing the decay of the orbit and eventually?
That's something we have to watch.
Yeah,
And this is kind of thrown planetary science theory on end when we're finding these massive
yeah,
gas giants closer than Mercury to
right.
their stars. I mean, that's,
And I've heard about a lot of them. I mean, it
Yep,
seems like there's a
yep.
fair number of
well,
them.
those are the ones we're gonna discover first. They're gonna be the ones that are
That's true.
closer,
Yeah.
using the methods that we have. So, yeah, we're just, I mean, you know, we've really just begun. And it's fascinating how we think we have a pretty good handle on things, and then you look at it, our solar system might be an oddball with rocky planets and gas giants. Nice job.
But yeah, so, any other questions for me? Okay, well, thank you.
You're up. Skywalker.
Let's do this.
Am I taking your job, Brianna?
Well, I mean, I'll go up.
Sorry. I didn't consider it. It's my last night, though. Sorry.
Yes, I learned from experience. So, I'm doing exoplanets. Welcome to the Exo Pioneers, rocking out of this world in your galaxy vacation. By my lawn name and then Logan's lawn name, who, again, is not here, sadly. Has never been here. The first one up is Kepler 438b. Kepler 438b facts, inner edge of the habitable zone, which is going to be quite a lot of these. Temperature 37 degrees Fahrenheit, and some of the dangers, or some of the bad stuff, as the planet is subjected to powerful radiation energy every 100 days, and violent storms erupt on it. Alright, now it's time for my personal favorite.
Here we go.
TRAPPIST-1! TRAPPIST-1b, extremely hot and thick atmosphere. The temperature surface is 890 degrees, can get up to 3,140 degrees Fahrenheit, much larger than Earth or Venus. Two possibilities of atmosphere, one rich in carbon dioxide, and one with water vapor, the more likely CO2. Kind of like the planet in which two friends fought for the fate of the galaxy. Anyone know what I'm referencing? Star Wars. Revenge of the Sith. There's a lot of Star Wars references because I love Star Wars. TRAPPIST-1c, rock-based Venus-like atmosphere. Habitable zone, like Bespin, where that one handsome rugged guy was frozen in carbonite and said, I know, and a son fought his father and lost his hand. Here's a bigger picture. Ta-da! Bespin, TRAPPIST. Alright, let's do this. TRAPPIST-1g, habitable zone, Earth-sized exoplanet, looks like Naboo, the one in which the race of beings say Misa a lot. There's not much information about a couple of these because they're incredibly new.
This is
So-
all in the same system, though.
Yes, all in the same system, all TRAPPIST-1,
Crazy.
all orbit, all are on the same star, and the one that looks like Bespin is very hot because it's right by the star. There are 3 planets right by the star. So you can imagine that they're pretty hot. That would basically burn your skin and you'd probably not be alive. Alright, TRAPPIST-1d, inner edge of the habitable zone, 30% of the mass of Earth, compact hydrogen or atmosphere. 4.3% more sunlight than Earth. Wow. Uninhabitable atmosphere looks like the planet is covered. Looks like the planet that is covered in trash and cleaned by one little robot in a Disney film. This one was pretty much a short presentation because I had not much time. Thank you for being such a great class and audience. Thank you very much! Oh, there. Short, simple, to the point.
All right. Now, we're gonna talk a little bit more about stars. We didn't get to this when we got the star unit.
like, it's just,
So,
no.
you're offline.
Okay. All right,
All right, here we go.
so we had binary star systems. Before we start out, has anyone ever seen a binary star system, ever? Okay. Let me ask another question, have any of you seen Star Wars? Because, well, you guys have seen a binary star system. So, just shocker for you right there.
Okay, so you're probably wondering, how does this form? And it's the same concept as how a planet formed in our solar system. So when the first star forms, you have all this gas and dust around the star. But when in our solar system, it formed a whole bunch of planets. But in a binary star system, it would form another star, and then the two stars would end up orbiting each other. So you get something that looks like that.
So is this normal? About 85% of the solar systems that we know of are actually binary. We're pretty rare for what we are for a singular star solar system. If Jupiter had played out a lot differently, we could have been a binary star system. But not only are there binary star systems, they have triple, multiple, you get the picture, there's more out there. I'm gonna have a video.
When most people think of solar systems, they likely imagine a bunch of planets zipping around a single sun, and that's the way it is in our own. It's not the case for all of them floating around in the universe, however. Some have as many as 4 parent stars. NASA recently discovered just such a system, making it the second of its kind known by the agency. They'd had their eye on one of the planets associated with the stars for a while, but for most of that time believed that it was in a 3-star situation. The discovery of the 4th sun leads researchers to believe it may be a more common configuration than previously believed. Their next step is to learn how having multiple parent stars can affect the development and behavior of the planets influenced by them. Information gathered previously suggests that it can alter their rotation patterns and size. It's believed that the presence of numerous solar influences could trigger excess growth, resulting in the formation of enormous planets. The star recently discovered does not appear to have influenced the orbit of the massive planet in the quadruple star system, a mystery researchers plan to investigate further.
So yeah. Oh, son of a gun.
So there's multiple different types of a binary star system. I'm going to tell you about the 2 main ones. So the first one is a wide binary star system. And in this, the 2 stars are farther apart. So their orbits keep them separated, they evolve separately, and they, at some point, are thought to have contained a 3rd star that was either absorbed or something happened to it.